Hey, so this talk is about encryption in transit. So the reason I'm putting this together is every time I've worked somewhere where we've moved to the cloud, suddenly people had to work or learn how encryption in transit actually work, because they're now required to do HTTPS between all their servers in their cloud environment and between their cloud environment and on-prem. So I'm going to talk about securing data in flight. I'm going to talk about the various topologies and different kind of data center setups, about asynchronous encryption in general. I'm going to talk about certificates, which is actually how we control the encryption keys. And I'm going to talk about the trust chaining and the hierarchy for certificate authorities and certificates and the impact of those on your applications and what that means. So what I'm not going to talk about, I'm not going to talk about a whole bunch of stuff. Encryption at rest. We're not going to talk about secrets management, which is its own discussion. If you do certificates and you do encryption, you got to manage all those secrets. Not talking about rolling or expiring certificates or how you would implement that where your certificates don't expire. And we're not going to talk about wildcards or subject alternative names or some of the fancy things you can do with certificates. And I'm not going to give any programming examples. So if you're looking for a programming example, maybe that'll come in a later talk. So the concept and components, you can kind of get the theme on this. This was supposed to be 9 bullets for the 9 layers of hell with certificates. The main idea is that everything you do with encryption or data protection in the cloud really comes back to certificates. So if we're doing internet traffic and we're protecting that within HTTPS, that's really goes back to certificates. If we're in the cloud or anywhere else and we're protecting in-flight, HTTPS, or other things, like if you were doing an Oracle database, you'd do encryption, or if you're in the cloud and you're doing Postgres, you're going to do encrypted in flight. All that's going to come back to certificates. In a hybrid cloud environment, you may have kind of a basic trusted environment set up on-prem. When you get involved in these hybrid cloud situations, suddenly you end up having to get involved with encrypted traffic inside your own data center, the hybrid data center. So maybe the traffic on-prem or in your old data center stays the same, but when it talks to the cloud or the cloud talks to it, you're going to want to encrypt everything in transit, just the way it works. I'm going to talk a little bit about the trust chain. So that's when you have certificates or you're trying to figure out when you connect to a host, is that really the host you think it is? And should that host be trusted? That's the trust chain where you're trying to make sure that the identity that these nodes cough up is actually trusted and they are who they say they are. So there's verification and repudiation. So one of the things you get when you do encryption or when you do certificates is you can actually repudiate it. So if your site was cracked, or somebody stole your certificate and you don't want anybody to be able to use that certificate to spoof you, or somebody left the company and they took the keys with them, you can actually cancel certificates and reissue them. And so even though a certificate hasn't expired, you can cancel it. Again, it goes back to certificates. The last part of this, I'm actually going to talk about different kinds of trust chains. So one of the things that happens is you have different issuers for certificates and they have a different amount of trust, and those have impact on how you operate within your data center. So when I talk about encryption topologies and the various flavors, what I really mean is it's the configuration for your data center and the configuration for your various servers to talk to each other. Most people, now this kind of depends. If you're coming out of a on-premises or hosted environment where you own your own machines and then you're moving to the cloud, that's going to change the way it looks. If you're all in the cloud already, it's going to look different unless you're like a startup or some company that really didn't think about, was more focused on some delivery and then didn't think about the security aspects of that. So it kind of depends. So internet traffic protection with HTTPS and TLS. So HTTPS means secure HTTP. And all it really means is that data is encrypted and you can verify that the host you're connected to is the host that you think it is. So data is protected in flight, right? HTTPS is only useful in flight. When the data is on the server, it can still be stolen or something else can happen because it's no longer encrypted when it's on the server. Data is protected in flight and it's encrypted. It's protected via encryption. And this is normally implemented with TLS. It used to be called SSL. That's been obsoleted. So you'll hear the term TLS now. So one of the things that happens here is when you connect to a server with TLS, the server identity is actually offered up in a certificate that's been verified by somebody. You can actually take that certificate and or that identity, and you can ask somebody else, another system, hey, is this server really who I think it is? You can actually be sure that the host you're connected to is what you think it is. You'll see this sometimes when you browse the internet and you'll connect to a host and it'll be like, this host, Google or somebody especially, Google's really big into pushing this. Google will go out and be like, this host that you're connecting to is not
who you think it is, or the identity in this that it's giving me does not match the SSL offering or identity that is coughing up. Browsers trust web server identity, so they have a whole trust chain set up in the browser where they trust certain entities to validate the servers are who they say they are. So the way the internet trust chain work is really you go to a server, it tells you who it is, you look at who is vouching for it, and if you trust the company that's vouching for it, then you'll trust that identity. So like in the case of Microsoft, they issue all their own certs. If you connect to a Microsoft site, you can look at that identity and you can go ask Microsoft, hey, is this really your site or not? Browsers, so most people when they interact with certificates or they interact with security, they really do that through the browser, and code has to do its own thing. But the browsers are set up in a way that they have a list of trusted parties. So when they connect to a server and that server says, hey, Billy over here or Microsoft or Thought or somebody else vouched for me that I'm really the site you think I am, the browsers actually have a list of trusted entities that they'll go to. And if the certificates or that site is vouched for by somebody not in the browser, you'll actually get a warning or an error. We'll talk about how that impacts people when they're in-house later. So it's just something to be aware. This is all transparent to you with the browsers because they try and simplify the user experience. If you're writing code, you have to do that all by hand. This one's really internet traffic. So if I have a website that's hosted on the internet and I've got a data center and it's got a bunch of service-to-service calls, or got some service-oriented architecture or something, or layered architecture, what does the inside of my data center look like and the outside? A lot of companies are set, it's a pretty high number because, to be honest, encryption is a real hassle. It burns resources. It's a pain in the neck. You got to manage certificates. You expire all this stuff. Everybody has to get smart about it. It's just kind of a real pain in the neck. So what a lot of people will do is they'll do HTTPS, and I think my mouse here will show this. They do HTTPS up to the edge of their data center. So the browsers or other companies connect to them over HTTPS with TLS. It's an encrypted link. And then that will actually be in the clear inside their data center, right? So what happens here is when you get to the edge of the company, those servers are actually vouched for by their certificates. When you get inside the company, you use HTTP, and you don't really know what that server is, who it says it is. You just kind of trust it because it's inside the company, and you assume nothing is misconfigured. And so there's kind of this whole implicit trust internal, whereas at the edge, you don't really trust any of the people coming in, and they're trying to verify that it's actually your site that they're talking to. So a lot of times you'll actually trust users once you're on the inside, and you'll actually trust your network team, and you'll trust your support staff, and so you want to encrypt on the inside. If you're in a completely cloud-based environment, most companies will treat that pretty differently. A lot of people will encrypt everything. So you encrypt everything in the cloud. Now, the reason for this is when you own your data center, it's only your people that can look at it. When you're hosted by a cloud provider, there's sort of this feeling a lot of times that the cloud provider themselves has access to your network and they have access to your servers in certain situations. So you should really run a kind of a trust no one encryption model here. So what people will do is they will encrypt all traffic in the cloud, and they will encrypt all traffic from the internet to the edge of their cloud. So in this case here, you can see with these servers, we have the same certificates at the edge, but in the background here, we no longer trust everybody. None of these guys, when they come in, actually trust the server. So we're going to actually put certificates on all the internal servers when apps or people talk to them. And so we'll actually have an encrypted link, both internal and external. We'll just pay that cost. So it's kind of a trust no one from the cloud provider point of view and trust no one on your network team. I worked one place where they mandated unencrypted traffic so that people could monitor the packets. A lot of places frown on that now. They don't actually want you to see what's in the packets because why would somebody on the network team be allowed to see data that's restricted or something? So the cloud, you kind of naturally do that. So basically the idea in the cloud is you're going to encrypt everything and you're going to block in-flight anybody from seeing in-flight data. So it gets a little more complicated when you're in a hybrid environment. In this case, we have, you'll see this a lot of times when companies have moved from hosting their own code to something in the cloud. So in this case, what we see is kind of the moving from edge to edge. You'll see the internet traffic is actually encrypted to the edge here. And then when they're in the cloud, they'll actually encrypt to all the servers in the cloud. So we'll have to talk about secret management in the cloud. They're a little bit, not secret management, but how the certs are installed. And then when that goes to the internal data center, what will happen is that'll actually be treated like a total security boundary, and there'll be SSL or TLS at the edge and authentication possibly and a bunch of other things. And then when you go back into the internal data center, nobody wants to go flip all that stuff around just because they're a hybrid cloud, so they'll leave the on-prem data center exactly the way it is. And in the example here, it's unencrypted HTTP with no server verification.